As the question says, a 6.5 meter long ladder rests against a vertical wall reaching a height of 6 meters. A 60 kg man stands halfway up the ladder. Find the torque of the force on end of the ladder, and B, assuming the weight of the ladder to be negligible as compared to the man and assuming the wall to be smooth, find the force exerted by the ground on the ladder. Now let us first sketch the diagram for this question, in which this is the wall and this be the surface, and this is the ladder actually of length 6.5 meters, and in the midway we are having an mg force due to the person. Now here it is in contact with it, so we will be having a normal reaction N1. It will be having a normal reaction over here N2. Since it is in horizontal equilibrium also, so there will be a force to balance N2, which will be a frictional force F over here. Now this is the scenario of the scenes over this ladder, and we need to find the torque of the force on the end of the ladder. So let us find it about this end of the ladder, that is this one. So we need to find the torque by this force on the upper end of the ladder, which will be simply that torque equals to mg, which is 600, into, since we have to find it about this point, this is the distance. So if we take this angle to be theta, then we can write it as 6.5 by 2 sine theta. Putting the values over here, we get 600 into 6.5 by 2 under root 1 minus 6 over 6.5 square, giving us a torque of 740 Newton meters. Now this was the first part. Let us proceed to the second part of this question, in which we need to find out the forces by the ground. So since we need to find out the N1 and F, let us balance the forces, that is the torque about this point A. Why we are taking this? Because the torque due to N2 will become 0, and therefore one variable will be reduced. So if we balance the torque about the point A, we are going to get mg into the distance between them, that is this distance, which is 6.5 sine theta, since this will be in the anti-clockwise direction, right? Now let us see the torque due to the frictional force F. This will be also in the anti-clockwise direction, so it will be added as F into the distance. Distance is this one, that has been given as 6, but let us take it as 6.5 cos theta equals to the total clockwise torque that is going to be applied, and that is due to N1, which will be N1 into the distance, and distance is this one, which is 6.5. I'm sorry, this was 6.5 by 2 because only this much distance was to be taken, right? Here it is 6.5 sine theta, right? And marking it as equation number 1. We know that frictional force is mu times N1, and balancing the forces in the vertical direction, because it is in the linear equilibrium as well, so we can write it as mg equals to N1, because it is the total downward force while it is the total upward force. So we got the value of N1 as mg, putting that over here. So we are having 1, 2 and 3 relations. N1 is reduced by mg, Friction is reduced by N1, so N1 value is to be put up there. So everything reduces into an equation in mu. So we can find out mu, which is coming out approximately to be 0.2. Now we have to find the actual forces. So let us take the vertical forces, which is equal to N1, and that is equal to the mg force, which is approximately 590 newtons, and let us take the horizontal force, which is due to the frictional force, and that comes out to be approximately 120 newtons.